The first step is to show it's true for the initial value of n. To step 2, this is where we make our assumption. In step 3, we want to show that it is true for n equals to k plus 1. In question 1, we want to prove that 6 to the power of n plus 4 is divisible by 5. So the idea is we want to somehow prove that this is divisible by 5. So the first step is to show it's true for the initial value of n. And that's going to be the lowest integer that satisfies this up here. So we start off by substituting in 0. So 6 to the power of 0 is 1. 1 plus 4 equals to 5, which is definitely divisible by 5. So we can say, therefore, it is true for n equals to 0. So moving on to step 2, this is where we make our assumption. So we want to assume that this is true for n equals to k. So how we write that is 6 to the power of k plus 4 is divisible by 5. So instead of writing equals to, which is what we did with the equations, we just write is divisible by 5 because that's what we're trying to prove. So using that assumption, we can say that 6 to the power of k plus 4 equals to 5m. So now we make an equation based on that. Because if it's divisible by 5, it means it's going to be any integer always multiplied by 5. That makes sense, right? If something's multiplied by 5, then we have to assume that it can also be divided by 5. So this is why we say 6 to the power of k plus 4 equals to 5m, whereas m is just any other integer. In step 3, we want to show that it is true for n equals to k plus 1. And that is, we write 6 to the power of k plus 1 plus 4 is divisible by 5. This is what we want to prove. Previously, we started off with left-hand side. Well, there's not really a left-hand side or a right-hand side here. We just start off with what's been given. So we have 6 to the power of k plus 1 plus 4. And now what we need to do is to manipulate it so we can make it equal to 5 multiplied by an integer to show that it's divisible by 5. Right? That's the best way to show it. So we want to manipulate it so we can factorize 5 out. So first thing we want to do is separate this into 6 to the power of k times 6 plus 4. And why I want to do that is so we can use the assumption that 6k plus 4 equals to 5m. So you can see that if I subtract 4 from both sides, I get that 6k equals to 5n minus 4, which is what I've substituted into here. So instead of 6k, I've written 5m minus 4. And now I just want to expand that. So 5 times 6 gives me 30n. Negative 4 times 6 is minus 24 plus 4, which is 30n minus 20. And factorizing out 5, that leaves me with 6m minus 4. So you can see that I factorize out 5. So we can say that which is divisible by 5. So therefore, it is true for n equals to k plus 1. Now, before we go on to the conclusion, I want to make a point here. Can you see that to show something's divisible by 5, I have to be able to factorize out 5. But the other thing is, what's in the bracket must be an integer, right? Because imagine if I had 5 times 6m divided by 4. Now, if this is a fraction, like 0.2 for example, and multiply that by 5, that number's not going to be divisible by 5, is it? Because essentially what you would have is 5 on 4 out here. So remember, you always have to check that what's in the bracket is definitely an integer. And you can see that because it's 6 times m, and m we made into an integer originally, minus 4, and there's no fractions or decimal places, then that must be an integer. So that's why we can say, therefore, it is divisible by 5 and true for n equals to k plus 1. So how we write the conclusion for this is, therefore, 6 to the power of n plus 4 is always divisible by 5. So as previously, we need to have this conclusion here, but the conclusion, rather than saying it is true for n is greater than 0 or 1, we say it's always divisible by 5.